The layout. So we have a conveyor belt that runs in a rectangle all around the system. And the stations are arranged around the outside of the conveyor belt. So the first station is, if you're going to do a multicolor box fill, the box gets put onto the conveyor empty because there's no beads yet. So it's going to get beads from any combination of the 3 filling stations. So the first station is just to put a multicolor box on the conveyor and send it along. The next 3 stations are the production tools. So the blue station produces, if you're going to produce a blue box, it just comes out of the blue station with blue pellets in it. Yellow comes out of the yellow, and red from red. If it's a multicolor box, it comes along, the station pulls it in, puts whatever amount you want of that color back on the conveyor, and then it goes down and gets whatever other colors it's supposed to get. So between these 4 stations, you can produce all the products. Once the products have been produced, and when they're produced, by the way, they get weighed. So the weight has already been determined. And these 2 stations check the volume. What they do is they just put a plunger down until it hits the top of the beads and measures how far down it goes. So the more beads in the box, the less the plunger goes down. And so that way you can calculate the volume. So once the box has been produced and measured, the next station puts the cover on and also a label on the cover, and the label has a date stamp so you can see what date it was produced. Then there's 2 stations that are used for temporarily storing the product if it's not ready to go out to the shipping dock or exit area. There's just 2 different ways, and they're arranged a little bit differently. The vertical stacker kind of has rows of boxes that are stacked above each other, and the horizontal stacker, they're all on one plane. So just 2 different ways of arranging the storage units. And then the last one is the delivery station, where the box is just pulled off the conveyor and put down a ramp. And that's where it essentially, if this were a manufacturing process, that would be, the products would then be packed onto cartons or pallets or whatever, and then delivered to the customer. So there's the layout of the system, representing all the different major parts of any manufacturing process. So getting down a little more into the details, looking at the stations. So there's a computer, it's a laptop computer that's the main server, and these are the 10 stations around the side. So every station has a local controller, and they're all PLCs, Allen Bradley Compact Logics 5330 PLCs. And in addition to that, every station also has a barcode reader. So you see this BCR means the barcode reader. And then there are a couple of stations like the blue, yellow, and red stations, because they're dispensing pellets. They also have a scale that's used to weigh the pellets as they're dispensed. Then there's another, on the label cover station, there's a printer that prints the labels. So those are all barcode readers, and scale and the printer are all third-party manufactured components that are brought into the system. And they all connect to the PLC by way of RS-232. Okay, so the next thing here is each PLC has an Ethernet module connected to it. And the Ethernet modules are connected back to an Ethernet switch, which then has a connection to the main server computer. So Ethernet ties each of the 10 stations together. Now the Ethernet module and the barcode reader are tied to the PLC by way of a technology that's been around for a long time. It's called RS-232. It's a 9-pin DB connector. You see them on older computers. It's kind of become obsolete because all these types of connections are now done over USB. But anyway, you'll see on every station you've got a PLC, an Ethernet connector, an Ethernet module, and a barcode reader. And so the barcode reader and the Ethernet are connected by RS-232 to the PLC, then the Ethernet ties to the network. Now there are a couple of stations blue, yellow, and red, where there are two different devices that need the RS-232. So the way those are handled is there's a relay that's installed. So if you want to read the scale, it's all serial data, so only needs one line. You flip this switch, the PLC runs a command to actuate an output that flips the relay, reads the scale, and then it flips it back to read the barcode reader. And then on the printer also is a RS-232. The only thing is that the data for the printer is coming from the PLC. So that's like an output channel on the RS-232. The barcode reader is going into the PLC. So the transmit line is used by the printer, and the receive line by the barcode reader. So there's no need for a relay there because they're using two separate lines. Okay, so this next section shows how to operate each of the HAS 200 stations. You're going to be doing this in the first lab using a panel of buttons that's on each station. So there's a power switch. Actually, the first one is an emergency shutoff. There's a power switch, start button, a stop button. This is the switch that flips from manual mode, standalone mode, to integrated. You're just going to keep that on manual for now, and then a reset button. So each of these buttons has a function. The first thing I'm going to talk about is how to make the station do what it's supposed to do. So stations 1, 5, 6, and 7, and 10 are all stations that do just one thing. They just, like the multicolor box feeder, puts a box on this conveyor. That's it. That's all it does. Checking station pulls the box in, checks the height, puts it back. The delivery just puts it on the output. So there are no options. So in order to operate them, you just simply press the green button once and let the station do what it has to do. If you want, if there's a box at the input of the station and you want it to just bypass the station without doing anything, you press the green button 4 times in succession, and it will pass it on. All right, so the production stations, the blue, yellow, and red productions, here we have some options. If you press the green button once, it's going to fill 15 grams of pellets. Twice is 30 grams, 3 times is 45. If you press it 4 times, well, if there's a box at the input of the station and you want it to pass the station without being filled with anything, you press it 4 times. Stations 8 and 9 are special. We're going to be getting more into those later in the course. They are the ones that store the boxes in any of, I think station 8 has like 81 positions and station 9 has 56. So in order to put a box into one of those little compartments, you have to use this HMI that's on the station. So it's a little bit of a special case. It's not simply a matter of pressing buttons. You actually have to give it some information. So we're going to be getting to that later on. Okay, so that's the standalone mode operation. You can also operate the station in standalone mode across the network by using this 3D Supra software, which is a type of SCADA software. So it gives you a 3D view of the station. It's a drawing that was done in SolidWorks, but it has moving parts just like the station itself. So as the station is doing its process, you can actually see the parts moving on the screen. So if you're in online mode, it actually gives you a live version of the system, kind of a CAD version of it. It also gives you a way of looking at some of the data, like the barcode number that was read, or the weight or height of the station. You can also operate 3D Supra in teaching mode, which means you can't really do much with it in teaching mode. You can just individually actuate some of the actuators, but mostly we'll be looking at it in online mode. So this is what 3D Supra looks like And if you double click any one of those stations, it brings up a large animation of the station, and it allows you to press virtual buttons that actually function like the real buttons. So this is what an individual station would look like. This one is I think this is the box dispenser for station 1. So it just shows you as the process is running, you'll see these parts moving around in a virtual space. Okay, and then the last level on the HAS200 is Edmus. That's their term. It stands for Educational MES. So this one allows you to put in a work order, track inventory, do you can rearrange material movement, data collection. It can also, if you have a problem on a station, it will allow you to pull the box out and re-enter, and it'll try to produce a new box in place. So it has that capability. Maintenance function, it actually can count how many times a given actuator has operated, and that's important for maintenance because after a certain number of 1,000 operations, for example, actuators have to be replaced. So that helps you to predict when something is due to be replaced. There's also statistical process control, which is a big part of manufacturing to keep the process from going out of spec, and even personnel tracking. I'm not sure if Edmus has that, but anyway, it's one of the functions. So, all right, so that's just kind of a bird's eye view. We'll be getting into more of this as we go through the course.